This is a video for the first lesson for Unit 12. We're going to learn how to multiply and divide rational functions. We've actually really learned how to do this already when we learned how to factor, cancel, and simplify these. We're just going to do that with multiplication and division. This notes page will be posted. A couple things. First of all, when you multiply, you're going to use the factor cancel method. Factor everything you can. If the same factor is in the numerator and the denominator, regardless of which fraction it's in, it will cancel. So there could be a factor in this numerator and the same factor in this denominator. Those would cancel even though they're not in the same fraction. Of course, they would also cancel if they are in the same fraction. The key is that one's in the numerator, one's in the denominator. To divide, you simply multiply by the reciprocal of the second fraction. Same thing you would do to divide fractions. You multiply by the reciprocal, and then you just do everything that you would do with multiplication. One quick note, no double dipping, because that's gross. Once a factor is canceled, you cannot use it again to cancel another factor that's the same. Last thing, we're also going to be stating restrictions. This is the place where functions do not exist. It's the same thing as holes in vertical asymptotes. In other words, we're going to look at the denominator's factors and find where they would be equal to 0. So we're going to simplify this first one, state the restrictions. And you can see I have several things happening here. First of all, in this numerator, I have a GCF of 5. And then that will factor again. I have a conjugate rule here, regular factoring, and another GCF here. So let's start with the GCFs. I'm going to take a 5 out of each of these three terms. Leaves me with 1, 7, and 12. I'm going to take a 10 out of these two terms. Leaves me with x squared minus 9. And you can see there's another conjugate. So let's go ahead and factor what we have. What I have is a GCF of 5. Factors of 12 that give me 7 are x plus 3 and x plus 4. Let's go down to this denominator. I have x squared minus 81. Conjugate rule, x plus 9, x minus 9. Factors of 27, x plus 9 and x minus 3. It has to be plus 9 because we need to get a plus 6. And then the x squared minus 9, this conjugate rule, is x plus 3 and x minus 3. So we've done all of our factoring, which I know you guys love so much. And we're going to see what we can cancel now. I see an x plus 3 here and an x plus 3 here, so those will go away. I see an x plus 9 and an x plus 9 on top, so those two will cancel. And I see an x minus 3 here and here that would also cancel. So the only things I have left is x plus 4 and an x minus 9. Now I also have this 5 and this 10. Just like any fraction, that would be 5 divided by 10. That would reduce to 1 over 2, or 1/2. So these factors would all cancel out and produce x plus 4 over 2 times x minus 9. Now what are the restrictions? The restrictions are going to be where x cannot be equal to because it doesn't exist. You know we can't divide by 0, so let's take this denominator. The 2 means nothing because there's no x with it. If I plug 9 in for x, I would get 9 minus 9, which is 0 in the denominator. You cannot divide by 0, so 9 is not something x is allowed to be equal to here because that would make 0 in the denominator. But it's not just the simplified form. We got to look back at all the denominator parts. X plus 9 means negative 9 can't be an x value. X plus 3, x minus 3. So negative 3 and positive 3 also cannot be x values, because if you plug any of these 4 x values in to here, or really into the original, they're going to give you 0 in the denominator, which is not allowed. All right, let's do a division problem. Again, we got lots of factoring to do, but before I do that, I'm going to take care of this division by multiplying by the reciprocal. So I change division to multiplication, and I do the reciprocal of this fraction. All right, so we're going to do some factoring here. The numerator, this is factors of 36, 6 and 6 add up to 12. Now you can write this as x plus 6, the quantity squared. I wrote it as 2 separate factors. In the denominator, I have a GCF. All three terms share 2 x's, so I take x squared out, 2 x's out, and you can see what I have left when I take those 2 x's out. This numerator has a GCF of x, so I take x out of both terms, and I'm left with this nice conjugate rule. and then this factors of 18 that make 9, x plus 6 and x plus 3. Now I do have to factor this and this real quick. So again, I have my 2x plus 6's, and I'm going to factor factors of 24 that give me negative 5. So minus 8 and plus 3, multiply to make 24, and also add up to make negative 5. And that conjugate rule, x squared minus 64, x plus 8, x minus 8. So now everything's factored. Now let's see what we can cancel. I have an x minus 8 that would cancel here and here. There's 2 x's here and 1 x here, and let me show you what that looks like real quick. What I have is an x in the numerator, and then there was an x squared down here in this denominator. So what that means is I have x over x squared, and x squared means x times x. So one of these x's cancels with one of those and leaves one x in the denominator. Another way to think of it, use the rules of exponents. 1 minus 2 is negative 1, and negative goes in the denominator. I like to think of it as I have 1x, I need to use that 1x to get rid of one of these two, leaving 1 left. So however you think of it, I'm going to end up with 1x left in the denominator. So I've reduced these x's. The x minus 8's are gone. What else do I have? Well, I do have an x plus 6. There's this x plus 6 can cancel with this one, but I can't cancel this because otherwise you're double dipping and using this x plus 6 twice. So this x plus 6 down here will cancel with one of these up here. Now the x plus 3's, you think, oh, maybe those will cancel, but they don't because they're both in the denominator. The reason these are canceling is because something divided by itself is 1. Well, these aren't being divided, they're both in the denominator, so the x plus 3's don't cancel. So I have an x plus 6 left, an x plus 6 that cancels. This x cancels. I have an x plus 8 left. X minus 8 cancels. And down below, I have these two x plus 3's with the x. So I have x plus 6, x plus 8 left. The extra x in the denominator from the x squared. And the 2x plus 3's, and I just wrote that as a quantity squared. So let's look at our denominators for restrictions. X means 0 can't be in an x value, because if you plug 0 in for x, that would make 0 in the denominator. This x plus 3 means negative 3 cannot be an x value. We also had this x plus 6 in the denominator, so negative 6 can't be x. I also have an 8 from x minus 8. But I also have to include negative 8. And why would I use negative 8? Well, that comes from x plus 8. But you might say x plus 8 is in the numerator. And it is here at this step. But if you remember, that x plus 8 came from this original denominator. So that x plus 8 also has to be considered. Quick shortcut for that. With multiplication, you only have to consider the denominators. Boom, boom. In division, you have to consider this denominator plus both of these parts, because this was the original denominator. When you flip it, this becomes a new denominator. So you're really dividing by all three parts, this, and this up here. So you would consider all three of these areas for the restrictions. Make sure you get on and do the practice problem.